Will turn and Zach haven't turned in the correction yet.
Oh yeah.
And Derek haven't turned in the correction yet. Emily did. Trevor have not. Andrew Green have not.
I'm almost done. I have like literally one question.
Got a lot wrong.
Okay, so computer screen. Yeah, thank you. So this is a movie thing I wanna tell you. I don't know how many of you guys watched this movie. Great movie.
Oh, my sister watched it. I said no.
Hidden Figure. No, this is a good movie about.
What's hidden space?
You did not just say that.
Because
All right. Let me give you some background of this movie. The background of this movie is 3 black women back in 1960s when NASA was in Cape Canaveral, and they are proving to be one of the odd because one of the thing is this. Can you let me talk, Andrew, please? One of the thing is the 3 black women got pulled over by a white cops, and the white cop says, "What do you guys do?" And he's like, "I'm a NASA engineer." And the white guys literally just says, "I can't believe NASA will actually hire a black woman," something like that nature. But it was a great movie. It's like one of the movie I thought like racial injustice is really proving at that time. Not as much as it's more extreme at that time. So I thought it's a very, very good movie. And I thought like a lot of things like I think like I'm very, very pro this kind of movie is to think about, instead of talk about like injustice and we should talk about more about those people become successful that becomes more excel. And Katherine Johnson is one of them. Katherine Johnson is one of them. She's a black astrophysicist. She is better at calculation than anybody else. How many of you guys seen this movie? Raise your hand.
I've seen it, but I don't remember.
Okay, so basically she's just kick ass. And another movie thing is like talking about bathrooms. Like she's actually not allowed to use the bathroom in the NASA because they don't allow black women. And she had to like ride a bicycle going to like 20 minutes away and then use a bathroom and then come back. And his boss questioned her, says, "Oh, hi." His boss questioned her, says, "Hey, how come you always come in late? Every time you go in somewhere and come back, and she'll come back all drenched because of rain." So very sad. She's like, she got very pissed off. She says, "Hey, I had to use bathroom 20 minutes away, and I had to come back because NASA didn't allow me to use the bathroom here." I thought that movie really made me kind of want to cry about that situation because, and basically the boss take a sledgehammer and went to knock down the sign, says like white people only or something like that. And he's like, "It doesn't matter you're black or white, you pee the same." Greatest quote.
We all pee yellow.
Yeah, greatest quote ever, right? I think that's a greatest quote that ever invented on like a racial justice movie. I thought that was really, really profound. As far as this part, I think this is awesome movie. You gotta watch it. It's actually very good. It's actually really good.
Did you have
The scene is famous.
Okay.
I was about to play this.
So this is just one clip about the math, the calculus part. So basically, the whole backstory is they have problem. The Russia already sent the satellite to the orbit.
Oh, Sputnik.
I don't know what is it, but they send it Russia. They send it to the orbit already, and the president, I don't know who was the president at the time, says we had to catch up to Russia. We cannot. Russia becomes more advanced than we are. Andrew, Xavier, please let me talk.
We're talking about
I know, but let me talk.
Eisenhower.
Well, you can whatever it is. Eisenhower is in World War II.
Who's after Truman? Shut up. The Truman Show.
All right. So what happened is they're trying to shoot a rocket to the moon, right? Try to shoot a satellite to the moon, and they had problem with it. The biggest problem is every time the rocket go up, there were so many different variable because it's just not regular projectile anymore. It's not like you have potato launch, you just launch a thing and just go up in the air and come back down, which is the problem. With the rocket, it's different because the fuel weight is changing. Because as you go up, you consume fuel, and you consume fuel, the fuel change, the weight change. Okay, so those are different variation. Hold on a second. Those are different variations. That's only one element. That's the crazy part is the air resistance, the drag,
Gravity.
the pressure, the gravity. Yeah, they're all changing constantly, and they cannot properly predict that projectile to the, they call it go or no go positions, which is into the orbit. Okay. They cannot figure out with all those white engineer, but this black astrophysicist kind of figure out how things work. They actually stuff to her to give her all the busy work, just calculation work, not without thinking. So they just give, but she can do calculation. She actually corrected like computer's calculation in the movie. It's a really good movie. So basically it's the same. Give me some.
There's no mathematical formula.
There's no mathematical formula for that.
Landing, but without this conversion, the capsule stays in orbit. You can't bring it back home.
Maybe we've been thinking about this all wrong.
How's that?
Yeah.
Maybe it's not new math at all.
It could be, oh man.
Big Bang Theory again.
Something that looks like.
Let's watch this.
You can turn up on the
Why is it Dutch?
Subtitles.
Calculate launch and landing, but without this conversion,
Auto
the capsule
translate.
stays in orbit. You can't bring it back home.
Let's scroll down to English.
Later.
Maybe we've been thinking.
There we go.
How's that?
White language.
Calculate launch, landing, but without this conversion, the capsule stays in orbit. You can't bring it back home.
It's right.
We've been thinking
So,
about this.
It's from an elliptical orbit to a parabolic orbit. There's no mathematical formula. We can calculate launch and landing, but without this conversion, the capsule stays in orbit. We can't bring it back home.
That's a
Maybe we've
really
been
bad.
thinking about this all wrong.
How's that?
Maybe it's not new math at all.
It could be old math. Something that looks at the problem numerically and not theoretically. It's always dependent.
It is.
He's a good boss, by the way.
Euler's method.
Well, this method,
Yes.
but that's ancient.
Works. Oh, Sheldon. It works numerically.
It's
Actually, this Sheldon's actually always put her down.
Yeah,
Oh,
he's
really?
racist. He's racist.
That's it. Let's type it up.
So Sheldon, the guy on the left, right, supposed to be a lead engineer, but he seems like always have struggle come up with a solution. But she's always the one that come up with a solution. But he always try to put her down. So that's really make it really frustration about the scene of the movie. Yes.
I just want to say that I was right. It was Eisenhower that was president.
Oh my god.
And that's it.
You're not
19 which what? 19 which?
53 to 61. And Sputnik was in 1955.
Oh, that might be after that though.
Yeah, but we were talking about when.
So actually, you're wrong, Derek. So
No,
please just stop.
we were talking about when Russia released the document.
I think there was
And
this
we had
was
the president that wanted to go. I was like, that was Eisenhower.
okay. I just assumed you're right.
I'm right.
Okay. All right, teaching with iPad.
Whoa, transition.
Yeah.
I'm gonna say.
So the Euler's method. Now just think about there was some type of projectile, and we're gonna create a situation. I have no idea what happened with the real math, so I want you to come up with the Euler's method. I want you to come up with it.
I'm gonna be. I'm not gonna be Euler right now.
Well, you are today.
I got a really good way to figure it out.
Wait, do you think I could work it now?
All right. So let's just say there's some type of projectile, right?
Maybe like the rocket problem from PSA2.
And we're gonna say this is x0, and this is called the exact solution, which is we don't have, because back then the computer is maybe 64 kilobyte. It's very, very minimum. Just think about the RAM that we have is about 8 gig on the cell phone. You can even get higher. So 64 kilobyte cannot do anything. The calculator of TI-32, it's probably big as this room. Okay, so that's how crazy, and they depict that thing in the movie as well. So obviously we have one point of the, let's just say we have a 1 point of bracket. And so we're gonna, oh, I'm sorry. We're gonna show you the, we're gonna show you that this part is gonna go from this point, and we're gonna try to approximate a solution. A solution is gonna be basically, I'm gonna use this tangent line here, and we're gonna predict, like, let's just say how high this point is. We're gonna predict this, how high this point is.
What do you have two other dashes?
So we're gonna call 2 steps. We're gonna break up to 2 steps, and we're gonna talk about that in a second. So this is the exact solution, but back then computer not able to generate like this fast. So I would say that you need some type of thing. So we're gonna build a tangent line, and we're gonna build the equation tangent line. So we're gonna try to draw a tangent line, and to like maybe this point here, to this point, we're gonna call that this one is gonna be slope, and that's gonna be f of x0 y0, and then you're gonna use this point and use that slope of this point. So you're gonna say and to get to this point. Okay, so the second point is gonna call it x1 y1, and to predict that this height, so x,
Not at the not on the graph anymore. It's just on the tangent line.
yeah, so you're gonna base out here, you're gonna have a new slope generate based on the new x and y value to find out how high this object at, let's just say for example this is a 1, this is 2. You're using 2-step process to figure out there. Robert, why are you falling asleep? Okay, so so you want to figure out this point. Now here's the thing, it's actually a very simple math. Just do 2 equal interval and do 2 brand new equation tangent line approximation.
Oh, you use systems of equation?
No, there's no system equation involved. So this point here, you're gonna draw a tangent line to approximate this value. Last year we already did this. Something that's really small is gonna be insignificant. Let's say 0.5 away, it's gonna be insignificant. Yes, Robert?
So how do we know like when to stop? What do we go to?
Well, we want to approximate at, let's say if we're at 1, I want to approximate at 2. How high is it at 2? But we're gonna use 2-step process to get there.
So when do you know when to put your second point? Like when do we know when x1, y1 is?
I will give you an initial condition. I'll give you this conditions here, and then you're gonna use the equation tangent line to approximate this point. You did this before. It's using, like they will say on last year for AP exam, they will say use the equation tangent line to approximate f of 1.1. Okay, and we did that before. We just did the equation tangent line and did there. So and then here we're gonna use the thing is that today we're gonna give you a differential equation, which is the slope dy dx. dy dx is gonna give you a slope at a particular point. Now you're gonna base on this new point and do an equation tangent line again to approximate this. So you're gonna use the equation tangent line twice to approximate. Now realize something. When you go up in the air, right? When you shoot a rocket to the moon, or to the orbit, when they go through the first phase, the fuel is you consume at the first phase. They have first phase, second phase, and third phase of the fuel, right? So each phase that your weight's got reduced. So you still exert the same amount of power, but your weights change. Do you see what I'm saying?
So it would be getting faster.
I don't know. I don't know the astrophysics part, but I think I can safe to assume that this is a very easy approximation. But back then you don't have a computer so advanced, so you had to do approximation. So that's why they say OMath. OMath is just basically use an equation tangent line to approximate this point. And at this particular, you have a slope, which is maybe the speed of the rocket fuel, and it's gonna go like this, but it's based on a different weight now. So those are things that I don't know how to exactly the math. I'm not astrophysicist, so half the thing I say might not hold true. But I'm gonna say for Euler's approximation, this is how the way is. So I'm gonna give you a situation, and I want you to predict that what is a value of 3 using Euler's method. So this is the question to start with. Dy dx. So I'll give you the slope. A differential equation. The dy dx, which is represents slope at any given moment, is equal to y squared minus xy. Okay. And I'll give you an initial condition. So at 2 minutes later, your rocket is about 3 miles away from the Earth, something like that. That's the one thing. That's the first thing. Now this is called a differential equation. This is the homework you have to do because this is 4 points on your AP exam. Every single individual have to get all those 4 points in here. I don't care how bad a score you have. I only care about if you get the Euler's method right, because that's the question. Is 100% is going to give it to you. So this is a differential equation. Now what happened is, can you approximate? So can you approximate y to the 3 obtained by Euler's method, which is equation tangent line, but twice. Euler's method with 2 steps. And what I mean is 2 steps is this. You're gonna use each step. So for example, if you 2 to 3, if it's 2 steps, the first one is from initial condition. The second one is the halfway hash mark, right?
So 2.5.
Yeah, probably. But also to put in mind the y is changing, right? Because you base on equation tangent line. So what you're gonna do is you approximate y to 3 using this differential equation, which is given right here. This is a differential equation. And then this is the initial condition. Just say maybe 2 minutes later, the rocket is at 3 miles away from the face of Earth, or 3 kilometers from face of Earth. So what happened at y3? Okay, so 2 steps. So maybe I hear this, we're gonna say this is x equal to 2. It's 2.5, and this is 3. I want to figure out how high this object is.
Is it the same problem?
Huh?
The
Maybe, no, I'm just, this is not the same graph, but this is the same idea. what you're gonna do. Okay, so I'm gonna give you 10 minutes. Everybody work with each other, figure out. Last period, people that figure out are Jinju, Gage, Zach, not Zach, no, sorry, not Zach. Will, not the smarter Will. No, I'm just kidding. The Will, Sheila, Sarah Ruby, Kevin Gage. Yeah, so those are a few people that figure out. So I think you guys can figure out too, but you guys need to learn how to work together. Bristol was very impressive today. He actually, 3 people in his group is all earned a 5. He earned 3, but he was correcting all those people who had a 5. So it didn't matter what your knowledge is. There's a possibility you can correct other people's mistakes. So you want to. I'll give you an answer choice too. Should I give you a multiple choice answer?
Yeah, because I want to see if I've gotten it right. If my answer's up there.
A is 0, B is 4.5, C is 6, and D is 9.
Okay, Xavier. Eat my work really quick. I just took these numbers, plugged them in here, and then you solve for the slope. And once you have the
That's a
slope,
good
you know the
estimation,
point
probably.
and the slope, you get the formula right here, and then you just plug in the x value for this, and you can solve for the y value.
I mean,
That is pretty good. You solve for the
Yeah, you have to use. I'll give you a clue. You have to use the equation tension line twice, but the new height change. A new x value, a new height.
I'm on. No, we took 2 steps to get from 2.5, and then does this count as more than 2 steps? Because that's the slope, and then I plugged in some numbers.
I don't know. That's what you guys did discuss.
I don't. I think that counts as 2 steps. I got. This is the final answer I got. Yeah.
I cannot tell you whether you're right or wrong.
Right. Okay.
I would feel crazy bad if the
Water
answer
was
was
A0, and like Yule's method is actually like, oh, it's always 0.
No.
That doesn't make sense.
So now you can serious, Xavier.
Because let's be real, Xavier. The graph look like this. Get real. That's what it looks like.
Time is ticking.
No, that's not what it actually looks like. That was an example of even.
Yeah, I know we don't really know exactly what it looks like. But I think this counts as 2 steps, Xavier. That's step 1 and that's step 2. There's like ways you could condense it. Because it's literally just plugging in numbers. I just don't remember. Yeah?
Whoever come on the answer first, you got cup seat.
Okay, someone else.
Huh?
I said, now my brain's.
You would have to do one.
Now your brain's turned off.
Okay.
Tangent line.
If I had done it like that.
No, I get it.
It would be connecting the.
Yeah.
You have to be like, do this and then like do it. Yes. So it's
So I did get the first slope.
I know
right.
it's
The
hard.
number I need to plug in would be 2.5.
And I know you can probably,
Because that's
well,
half
but
of
you
it.
do have to allow some.
You know, I was freaking out that day. I think I was overreacting a little.
Yeah. What was Sheila?
So
What
what you get
was,
for
who else is there?
Yeah, she's behind right now though.
I know one
But she told me that like after she got off the good And then I'm also working with Katie now.
Katie's also in
Yeah.
Yeah, but I feel like understanding. I feel like I would trust Sheila slightly more. Katie's just a better teacher.
Oh,
Yeah.
Like it's something that is something very direct. Like, but for figuring things out, I think Sheila has more strength. I think Katie is a good student, but it's as far as to figure out things when things are not completely clear. I think Sheila has still slightly better.
Yeah.
But it's not nothing I don't want it both of us. So were you. So that's why I told you something.
It's 42.
49.
Close enough.
I mean, I'm inclined to think about two first to get rid of the decimals and just put 2 echelon on the bottom.
Oh, okay, so we're done.
I just
Oh my goodness, Xavier, this is a pretty. Here, you got
We
anything?
did like tutoring. Oh yeah. Yeah. Tutoring. Yeah.
Negative.
All over the desk. What was the difference between his tutoring and how he teaches?
Oh, you're right, we
He
definitely.
actually like slowed down. Cause everyone already took just one in that class.
Oh.
So he
Yeah,
like
'cause it
speeds
starts
through
going
everything,
down.
and I didn't take that.
Oh,
It's like,
So,
that didn't-
I'm not there.
yeah, I'm not gonna tell you anything, I'm just doing the math.
So y of 2 is 3.
What's plus 2?
Yeah, f of 2 is 3.
I'm just, I'm gonna take it out.
Wait, why?
Well,
Yeah.
Wait,
Why is the x the thing that's
slope?
with a 3
wait,
instead of the y? Shouldn't the y?
wait, where's the slope at?
that's the slope at every time. Like it doesn't matter what the x value is. That's dy dx is the slope.
Y of 3. Oh, that's an initial condition. Okay, that makes sense.
Like a half parabola
Robert, how could I solve
in
for
terms of y.
Why?
Yeah, I need to solve for y.
Plug in the x value.
Well, the final x
Oh,
value
wait,
we're solving
yeah.
for is 3.
Yes.
Why does that change how we
3
solve?
times 21 would be.
Yeah.
Wait, what did you have?
Keywords, 2 equal steps.
Don't worry about it.
We're told you
Got it.
1 is 2, 1 is 2.5.
200 divided by
Yeah.
4.
But you also produce a new y value each time, so
What do you mean two?
Do we have to?
I mean, like,
Wait, Will, do we have to?
you even have to take integration.
you don't have it's something to do with integration.
Right. Oh my gosh.
Right.
Yeah.
Didn't I just have it laid there for everything?
See, I'm getting decimals right now.
Don't use decimal, use fractions. Fractions are
So why
friend.
are you integrating?
Yeah, I'm a fraction enjoyer first.
Yeah, I hate decimals. The only time I would use decimals is in chemistry, and I hate chemistry. I don't know why I
Big
made it.
figs. Mr. Greenwald.
That's the thing. That's what they call him now.
What?
They
I
call
know he
Mr.
hates
Greenwood
that.
Greenie.
Y squared
Green now.
Yeah, I think I was better off with my first answer, Xavier. I think he screwed me out.
Sorry.
So,
Okay. So we have.
6, which is at least one of the multiple choice answers.
I had it right then. I'm probably equals wrong. You don't get this.
Heck! Way to go.
I don't think he meant to.
Way to go.
I think he would have said.
What do you
Good
got?
job, man.
I'm ready. But it's
What's 2.2?
Is that can you explain it to me?
No, Robert's asking what's the equation tangent line. And Zach's like, y minus y1 equal to m times x minus x1.
Alright.
He knows his point slope.
You have to know your point slope.
Yeah, I always feel like I got the wrong formula, and then I asked Xavier and I got it right, so I think I'm good.
Oh, this is 11 is 1. What's 11 times 11? I would.
It's 11 squared. Duh.
I get this question wrong. I'm killing me.
It'd be 110 plus.
Oh, it is 100. Yeah, but I think that way better.
If you're doing arithmetic in your head, fractions are bad. And distributed.
People who like decimals
I hate multiplied decimals. That's crazy. I don't even know how to divide decimal. I'm a math teacher.
Yeah.
I hate divide decimal. I was teaching my son the other day. I was like, wait, how do I do this? It's like, can I just convert?
Dividing by decimals is just like multiplying, but wrong.
Yeah, but the way you had to pay attention to space and how you move the decimal point.
Yeah, go Robert.
It's a pain in the butt.
Read your answer.
No, I figure out, of course, but
Just turn the decimals into fractions.
yeah, that's what I told him. But I said, yeah, but you do still have to learn how to divide decimal, even though you will
Oh,
use
it's
a
when
calculator
you'll
every time you do that.
I love that you tables though.
What is it? 1 minus
Oh my god, I got this green line back.
121.
I feel like the derivative is full of
That is so crazy.
Alright, so I took quick. I can't divide it once.
Oh, Mr. J, we have a stats test
So now I need to find y.
I heard
So
that.
he, plug in 2.5. Take 1 to 5.
We're on there calculating the problem.
Days in that? I don't know. I don't do that. I don't do arithmetic right, which is one of the reasons I'm so bad at it.
I think Katie shut up yesterday in the class and she just kept talking. Which made me mad. I'm not gonna lie. Like, she doesn't know the stuff.
At times, she can be distracted.
Y.
Sometimes I just tell her.
It's all nerd talk.
It's
I don't want to hear it.
55.
But
It is 66.
he talked about it's like the hardest math. I'm like,
This, and we're finding
I don't know about that, but.
Which is gonna show us like a really good way to do it like afterwards, and we're like, oh, it was that easy.
Say you binomial distribution type of guy.
Is if you have
I hope binomial expansion.
it's 11.
I read it correctly.
11 times 5.
Binomial
So 11
expansion.
minus 5 would be 6.
I feel like I'm good at everything.
55. And so then you get 6 times 11, which is 60.
I don't remember.
I didn't think about it until just now. I did it like regular.
My
But you could do
fire.
that.
Andrew, have you gotten an answer yet?
I got 6.
I got 6 as well.
Wait.
But I don't.
Can you tell me what you're doing?
Yeah, same.
You just, Xavier, you find the tangent line, and then you
Guys, hey, shh. I want to know. Tell me.
Yeah. Use that.
Tell me.
That's all I did.
Yeah, see, I.
But I'm in a good place.
Yeah,
I think you meant like there are 2 separate steps you do,
What are we doing here?
not like 2
I
intervals.
don't know if it's right though, right?
Oh, Michigan, are we doing 2 intervals or 2
I
separate
don't know if
steps?
it's right.
Like, where do we start?
I first.
But-
normal thing,
But,
But
but,
Oh, because you can.
Everything changes. everything changes.
3.
Everything changes.
What changes?
I cannot tell you.
I really don't know what you're talking
Wait,
about.
okay, so it's not.
One, you pick up.
Everything changes.
Everything.
Yeah, but I feel like the first part I tried. Yeah, I think it's right.
Yeah.
3.
divide both sides by y.
3 times x minus.
What you say?
If you try multiplying both sides by a factor.
You want to show me?
Like, this kind of super fun.
Okay, so I may not
Do
So
that
y
one.
equals 3x minus 3. I don't know
Yeah, and then
how.
I don't know what to do from there.
So you
Like,
just plug in numbers.
I plug in,
What is that?
Do you want to see everything that I did?
10 and I got the second thing.
Because like if I knew what I was working towards, it'd be easier.
Right.
3, but I don't think it's right because he said that everything
Yeah?
changes, so.
I'll think
maybe
6 was
that's
right
what
answer.
changed.
Yeah, I don't think so either. But I still don't really understand the question being asked.
I was literally thinking about
What's
sending
so
like $1 and asking if I could have Pepsi.
It's just wow.
Okay, cool. That is $1 million.
Hey, would you like to buy $10 worth of Pizza Hut?
No.
Maybe it's gonna give me one.
Outside Pizza Hut? Would you like to buy $3 worth of Papa or $10 worth of Papa John's?
I looked it up.
They didn't buy it.
Look up. You can look up boiling methods. It gives you no help in images. Like boilers, but
It doesn't help you.
yeah, if you look at like I looked at images and it was like no help.
Is it confusing? Is it more confusing?
The biggest help was this guy right here. No one will pay the line.
Okay.
So,
Alright, that's done, alright.
I got the 3, you got the 4.
How did I-
That's
I told you. I mean, sometimes it doesn't. It's just like a matter if you guys want to try or not. It's, if I ask you to try, that means you guys have enough to pull through.
I answered the 10 and then it's not like that's why it's like going on with this.
So Xavier, what method are you doing right now?
Everything.
But why would slope
So you just like create
I
a
don't know, it's
tangent
probably
line
not
that
like comprehending.
goes.
It shouldn't.
I feel like slope would not say the same, if you ask me.
Yeah,
I think that's a good observation.
I don't get why.
Because like if we're taking.
Did I say everything changes?
Yeah.
Everything changes.
That's where your first problem is. You're staying one dimensional.
Okay, yeah, I got 55 over 4.
Shut up, Will. Nice. Each are trying to sound smart.
Can you tell me what you did?
It's not right.
I got 55 over 4. I think it's.
I think mine might be.
Wait, what'd you get?
55 over 4.
Yeah, oh, so did I.
I got 6.
Oh, yeah.
Oh, yeah,
I got 55 over 4.
Well, did you actually get as
No. I was sorry. I didn't mean to bring your hopes down. It's okay.
If everything that means the slope changes. Everything changes with the slope change.
Well, yeah, that's what the point of the two intervals is.
Okay, so.
Don't let them talk to you like that, alright?
I did it wrong anyway.
Okay, so we'll do slope. Okay.
What we do?
I don't know.
Oh,
Slope is not
Someone
changing.
phone over there, not helping out.
No, I
at all. Not contributing anything to the slides.
I'm literally looking at.
Sure.
Okay, so slope is not be 3. What if it is 1 over 3? Negative 1 over 3.
Well, I mean, in that picture, it looks like the slope increases, right? Was that picture the graph?
Oh, that's not may not be the best picture because I actually don't know what this differential equation is.
Realize the graph is not the best.
Let's
That's not gonna help
step
you.
by step. What did you guys get for the slope at x equals 2?
4.5.
And I
No, at x equals 2.
4.5.
3.
No,
3.
is that what I got? And then x, no, and then I think you're talking about x equals 2.5.
I also got 3 for that.
You also got 3 for f of 2.5?
I shouldn't, so that's where I'm
Okay, do you convert it to point slope form after you found the slope of x equals 2?
What's slope for?
How much time we have?
We have
We have to go over the question right now.
Yeah.
I want to know.
we go to the question, like, if
All right.
homework for this.
So for me, like just understanding what is going on. For me, like the easiest way to think about is this: is I will establish a chart, and this chart is gonna be based on x, y, and dy dx, because everything changes. So you start with a 2, and that's your initial condition. You're gonna plug in to get the slope. So in this case, what is my slope? It's gonna be 3 squared minus 2 times 3, right? So that's equal to that's equal to what?
3.
That's equal to 3.
Yeah, because it's 9 minus 6.
Okay. So now this dy dx is 3. So you're gonna use this, draw equation tangent line. So y minus 3 is equal to 3 times x minus 2. Now, what you're going to do is you're going to figure out, use that first initial condition. Figure out what happened when x value is 2.5. Because 2.5 is a halfway mark, right? So then I can plug in 2.5. Because that's going to give you approximations. So that's equal to y equal to 3 times 1/2, so 3 over 2 plus 3. That's equal to 9/2.
It's not 1/2. It's 2.5, which would be like 5 halves, right?
It's 0.5. It's a half times 3, so it'd be 3/2.
That's
Then-
that's 2.5, not
Yeah, it's
0.5.
So it should be 15 over 2 plus 3.
It's
Yeah.
2.5, not 3.5. It's 2.5.
Yeah, 2.5 times 3 is 15 halves. not
No, 2.5 minus 2 is half.
Oh.
Half times 3 is 3/2. 3/2 plus 3 is 9 over 2.
Oh, you did it. That makes sense.
PEMDAS, guys.
Okay. A little slow, but it's okay.
Okay.
I got the second one wrong. Okay, that makes sense.
So if you realize a new coordinate is no longer 2 and 3. The new coordinate is the first stage. Let's just imagine that you have a rocket, right? You release the first field already. Now that field still gonna provide a similar slope, but then you have different weight. So you have to say, okay, well, here we got a new coordinate. The new coordinate is 2.5, which is we're gonna say 5 over 2 because I like 5 over 2 better, and I'll use 9 over 2. This is a new coordinate. And then we have to figure out the slope. So the slope is going to be, they say y squared, so it'll be 9 over 2 squared minus 2 times 5 over 2 times 9 over 2. So this is going to be 81 over 4 minus,
Was 9.
So I had the right idea. I just screwed up the Man, the algebra.
This is a 45 over 45 over 4, right?
Yeah. But you're gonna
I don't
multiply
think
by
it's
two,
45 over 4. I did something wrong.
Process of elimination. My mind says
It's a
you answered
45 over
it.
4, so it's equal to 36 over 4.
Whoa, you didn't multiply by two though. It should be minus 90 over 4 at the end, because it's 9 times 5, and then all that's times 2.
Yeah, on the other hand.
Yeah, and then here I will do use approximation again, so it'll be y minus 3. Now y minus 9 over 2. I think I did something wrong, but I don't know where.
When you multiply 5 over 2 times 9 over 2, you have to multiply 2.
So what am I supposed to get?
So it should be minus 90 over 4. So that should be negative 9 over 4 instead of 36 over 4.
No, it was answer is 9.
Yeah.
The this part is 9. I just don't know where I did my math wrong. So it'll be x minus 5 over 2. And I'm gonna multiply. I'm gonna put in 3 here.
Maybe alright.
So it'll be 9 times 1/2 y minus 9 over 2. And the y is equal to 9 over 2 plus 9 over 2. That's equal to 9. But I don't know what I did wrong here. 81 over 4 minus... Oh, I don't know why I got a 2 right there. I'm not supposed to have a 2. So let me cross out this 2. And then it's 45 over 4. And that's equal to 9. So I use the equation 10 to 9 twice to come out with it. It's not a big deal. It's just knowing it changes afterwards. Because you do have a different fuel at that time. Good job, Robert. Too bad you want to be a baseball player, because I do think you have an engineer brain. You might be able to do both. After career. Okay. Do you understand? Where did you mess up?
So I started doing the dy over dx thing, but somehow I got like negative 27 over something.